Hi students, I think I need to talk to you a little more on the Dual H bridge driver. I've shown you how it works, but maybe I need to talk to you in a little more details, okay? Right, let me take off the jumper cables first and bring the H bridge driver into view. Let me bring the camera closer so you can see better. Right, okay, let's talk about it. This chip here, the L298N chip, is designed for inductive loads and like solenoids and DC motors. Okay, it has 15 pins. 6 of them are for logic inputs. They're commonly called, this is here, the 6 pins. They're commonly called ENA or enable A. Next one is IN1, input 1, followed by input 2, input 3, input 4, and enable B. Okay? First 3 pins control the output 1 and output 2 ports here. And the other 3 pins control the output on the other side, port 3 and 4. 3 and 4, okay? There are 2 pins on the chip for the TTL logic and the high voltage input. And the remaining 3 pins are the grounds. The way the chip works is by taking signal from these input pins and through a series of AND gates to process the signals, which then control the open and close of the transistor inside. Basically, the transistor are the H bridge in the chip. You can look up the circuit diagram of the chip online if you are interested, but our focus here is how to operate the motor driver. So, in order to activate, say, a motor connected to port 1 and 2, 2 conditions must be met. And they are that ENA, enable A, must be active, and either pin 1 or input 1 or input 2 is active. The input A is kind of acting like an activation switch, and the input 1 and input 2 pins are for the directional control of the motor. All 6 pins can take in pulse width modulation signal or PWM, and it's up to you to decide how to use the pins efficiently. Some of you may have noticed that, if I could show you, some of you may have noticed that enable A and enable B pins have jumpers on them. This enables both sides of the output to be permanently active and reduce the pins required from Arduino to operate the motor driver. The downside is that you now have to use 2 PWM signals in order to control the clockwise and counterclockwise motor speed. In your project, you think about how to minimize the pins usage, and especially if you have multiple motors and other outputs to control. If you have 4 motors and if you're using 3 pins for each motor for the control, you'll already be using 12 pins from the Arduino. Think about that. On the other hand, if you're just using the PWM signals to control the these 2 pins in and have this one permanently connected, you'll be using a lot of PWM signals. And bear in mind, the Arduino only has 6 pulse width modulation signals. This is the last part of the demonstration for the electronics. I hope you enjoy it. Goodbye.